Hello there, Wildcats. Today we're going to talk about altitude and median in the triangle. So as you can see, the definition is given there. An altitude is a perpendicular segment, meaning when we say perpendicular, they will form a 90-degree angle or a right angle segment from a vertex. Okay, a vertex it's a tip of the triangle to the line containing the side opposite to the vertex in here. So as you can see, so from A, okay, from A going to B, this broken line here, when they form a 90-degree, therefore your altitude AE, so your altitude here is AE, which is perpendicular to DC, while a median of a triangle is a segment that has endpoint at a vertex and the midpoint of the side opposite to the vertex. So we're going to discuss the uses and the relationship of your altitude and your median. Now we are going to proceed with our first example on median. So I want you to look at this first example here on Theorem 5.7, concurrency of median. It says there that the median of a triangle are concurrent at a point that is two-thirds. So I want to focus on this term here because we'll be using this one to solve a given problem. Two-thirds the distance from each vertex to the midpoint of the opposite side. Now, if applying this theorem, we have in here the illustration. So you will see this median here. You're connecting A to D is a median. C connecting to F, going to F, that's a median. That divides the side of each triangle to be congruent. So here AE is congruent to CE, CD is congruent to BD, and AF is congruent to BF. Therefore, you have AG, this AG here, that's AG is equal to two-thirds of AD. Also, BG is two-thirds of BE. And CG is two-thirds of CF. So we are talking about measurements here. Now, we are going to apply this theorem in solving this problem. It says there, what is the length of Jn in the figure? Now, identify your Jn. So this from this point N going to J, that's what we are missing. That's we are going to solve. And we have a given which is 18. So JQ is 18. So JQ is 18. Now, to solve that, you can now say, okay, we are basing our answer on the theorem because that will be our justification, okay? So we have two-thirds of Jn, okay, is equal to JQ, okay? And we know that two-thirds of Jn is equal to the measurement of JQ, which is given from J to Q, is 18. Okay, now you have to solve this one. So your Jn here, so to solve and get rid of the two-thirds here, I'm going to multiply both sides by 3. Okay, so what you do on the left side of your equation, that's what you do to the right side of equation also. So this will be cancelled. So you have 2Jn is equal to 54. Okay, and then I'm going to divide both sides by 2. Okay, therefore Jn, which is the problem now, it's 27 units. I'll fix that. Jn is 27. Then I'll tax that because we already answered our problem. As easy as that. So we are basing our process based on the theorem that we have about concurrency of um, median. That's 2/3. Okay, 2/3 the distance from each vertex to the midpoint of the opposite side. Now let's do this one. Oh, orthocenter. Orthocenter can be found using construction or coordinate geometry, where is the orthocenter of a triangle KLM. When we say orthocenter, this is a point of concurrency of the line containing the altitude of the triangle. So the orthocenter is outside an obtuse triangle and inside of an acute triangle. Okay, so we will be applying this one. This might be a little long. It is because what are we going to do is we do it step by step. Okay, step one is we have to find the slope of two sides of your triangle. So I'll be doing slope of maybe I'll do KL, this one. The slope is equal to 5 minus 0 over 10 minus 0 is equal to 1/2. Okay, the slope of this one, it's 1/2. And then we also have to solve for maybe slope of LM. We only need two sides of the triangle. So LM is equal to 12 minus 5. That's 12 minus 5 over 3 minus 10, which will give us -1. So those are the slope. Step 2 is we have to use a point slope form. This is the step 1. Step 2 is use a point slope form. Point slope form. Okay, so point slope form will be y minus y1 is equal to mx minus x1. To write an equation of the altitude perpendicular, so perpendicular to KL and LM. So what are we going to do is we are going to connect M that is perpendicular here and that is perpendicular also with the L. So we do start with KL, segment KL. So we are looking at what is perpendicular to KL. Okay, what is perpendicular to KL? So y minus 12 is equal to -2. That's the times x minus 3. Okay, and then we do y is equal now to -2x plus 6 plus 12, and then we have y is equal to -2x plus 18. Okay, Mr. Where did you get the -2? It's like it's the -2. Take a look at this one. We have to get -2 is the negative reciprocal of 1/2. Okay, so always remember that when we talk about a line is perpendicular to the second line, make sure that your your slope are negative reciprocal or opposite reciprocal of that line. Okay, next is equation perpendicular to LM. Perpendicular to LM, we have y minus 0 is equal now to, looking at this one, LM 0 is equal to 1 negative reciprocal times x minus 0, and then we have y is equal to x, this one. Okay, step 3 is we have to solve the system of equation to determine the coordinate of the intersection. So we have to use systems of equation. We'll be using y, I'll be using blue here. Y is equal to negative 2x plus 18. And then the other equation is y is equal to x. And we said that y is equal to x. So I can plug in my y to be an x. Okay. So what I'm going to do is, because y is equal to x, then I can substitute y in here, or you can substitute x to your y. So I'll be doing x is equal to negative 2x plus 18. Add 2x both sides plus 2x. This will be cancelled. So I have 3x is equal to, I'll make sure that I write it properly. So 3x is equal to 18. I'm going to divide the 3 both sides. This is 18, guys. So that's 18. So x is equal to 6. And of course, because y is equal to x, therefore y is also 6. Therefore, okay, the orthocenter of triangle KLM is at 6, 6. So if I'm going to plug that in, 6, 6 is here, 6, it's here. Meaning, if I'm going to draw a line, that's the intersection of this 3 median that we have there. So that is how you find your orthocenter. One is to find the slope of 2 sides, and then using those slope, you have to find a the perpendicular to each of the side, and then use substitution and solving the value of x and y, and that's the orthocenter. So you can go back on this one to review how you do it. If you have any question, just let me know, and we'll see you in the next video, guys. Bye bye.